Okay, now continuing with different versions of STP. All right, as we've already seen, we have STP for VLANs, which is PVS, PVST, right? Those are different versions of VLANs, depending on the number of instances we have, depending on, for example, the number of port states that we have. We now have different forms of STP. The original one, which is STP, right? It is standard IEEE 802.1D, right? Which provides a loop-free topology in a network with redundant links. It assumes one spanning tree instance for the entire bridge network, regardless of the number of VLANs, and it uses 5 port states, right? What usually differentiates all these types of VLANs? One, my number of port states, right? Two, number of instances. I think basically that's it, instances, right? So we have two things differentiating what we call differentiating the types of VLANs that we have. If we have 5 port states, we are talking of STP. If we have 3 port states, we are talking of rapid STP. So instead of having 5 levels that no one's of farm paper or port states, let me just say, let me just generalize 5 levels. We now have 3. What that means is in terms of convergence, in a 3 port states is much faster than in a 5 port states, right? So with RSTP, we have an evolution of STP that provides faster convergence as it simplifies things with only 3 ports, discarding, learning, and forwarding, right? So we no longer have, we still have, so the 3 states, the first 3 states, the disable, the blocking, and the listening. Esacompresswa kuita 1 inonzi discarding in this case, so that tive ne-faster convergence. That's why this one is called rapid STP, because it has less port states, therefore faster convergence. Right. PVST plus, this is an enhancement of STP that provides separate instances for separate VLANs. It also supports port fast. I think we're going to look at port fast. We're going to look at the BPDU guard as well. All right. It offers everything as mentioned above. So PVST plus, this is just for separate instances, which helps when we have multiple VLANs. So we can have a case where for each VLAN, we can have a separate root bridge instead of having one root bridge for the whole network. Right. Let's look at rapid PVST. Rapid PVST, it's sort of, in comparison, is the same as the difference between these two, STP and RSTP, in terms of faster convergence. Rapid in a faster convergence between these two, PVST plus and rapid PVST plus. This one is rapid because in a faster convergence, this one. All right, so this is the Cisco enhancement of RSTP, providing for a separate VLAN, separate instance per VLAN. Each separate supports port fast and the BPDU guide, right? Nyaya convergence is also being helped by this alternative port fast. I think it's being explained in the next slides. Right, let's look at MSTP, multiple spanning tree protocol. Right, MSTP, it creates multiple spanning tree instances. So you see, this PVST is just an example of MSTP, multiple instances being created. Right. Lastly, we have multiple spanning tree, MST. This is a Cisco implementation. Right. This one, as you can see, it's an IEEE standard. You need to be able to separate. I think you are going to be tested as this is a Cisco exam. You're going to be tested on knowing kuti zvinhu zveCisco ndezvipi, zvinhu zvemunhu wese ndezvipi. So you see MST, this is a Cisco proprietary, let's say Cisco implementation. There's a Cisco chatted. Yeah, that's MST, but it's the same name MSTP, which is an IEEE standard. So IEEE standard, the edutese, there's a manu ese, there's a mavenda ese. MST Cisco devices, but the function, I think basically it remains the same. It remains the same. As you can see, PVST is a Cisco enhancement as well of STP. There's Cisco. You will be questioned on knowing kuti zveCisco ndezvipi, zvemunhu wese ndezvipi, zvemavendors ese ndezvipi. Right, this is it for my different versions of STP. Let's look at my port states and port rows. Right, here we have, I think this is an explanation of the difference between STP and RSTP. Right, with STP, we have 5 master states, as I mentioned, 5 states. With RSTP, rapid, we have 3 master states. The reason being because of SI, a collapse with one state. What that does, it helps in terms of faster convergence. That's the whole idea. Instead of having all these states, could interface ranga shut down, now ndari activator, probably rutanga ripa block state or pa listening, rava pa listening, rarisiva ma BPDU, araenda pa learning, rakutsvaga kuti MAC address ndeipi, then rochitanga kuforward. In RSTP, we don't have that. Rinotongotanga is either riri pa discarding pekutanga, then from there rakutongeta learning the MAC address, rakutotanga forward. There is no listening phase. Maseconds akawanda anenge ari pa listening port state up. Probably 5 seconds being wasted with the port trying to listen kuti ma BPD user asvika here, depending nekuti hello time rakaita sei, etc, etc. So this is the difference. This explains the difference between STP and rapid STP, and mainly it is linked to the convergence after a change in the network. Right, in terms of my root ports, we'll see STP, my root ports here akafanana. Right, STP though it runs blocked port. Kuno kuti ne backup port ne alternate port. Right, best explained in this slide the difference between the backup port and the alternate port. Right, with the alternate port, we have an alternate path to the root bridge. The backup port is a backup to a shared medium such as a hub. So if we have a shared medium, hubs, you cannot have an alternate port. You have what we call a backup port because this is a shared medium. Right, with this type of medium, we have an alternate port instead. You cannot have a backup port here. I think that's the only difference between those two. All right, let's look at what else do we have. Port fast and BPDU guard. Right, what is port fast? Port fast is a mechanism we have that speeds up the network, right, by transitioning directly from the blocking to the forwarding state. So tine 5 states that I mentioned, from blocking, right, pampane disabled, blocking, listening, learning. Then lastly, we have forwarding. Right, yet not the port fast. When a port is configured with port fast, you know, but directly from this state to forwarding, you know, skip a state esa of listening and learning about the MAC address. Basically, that is what port fast is. Why? Quit road to any faster conversions generally. But most importantly, there's an issue here. When a device is connected to a switch port, the switch port goes through both listening and learning states. We know that. Each time waiting for forward delay timer to expire. This delay is 15 seconds for each state for a total of 30 seconds. So we have 30 seconds the repair. Right? So ndikabva from blocking to forwarding, by listening and learning state, I have 30 seconds. Things in between those states. This presents a problem with the DHCP clients trying to discover the server because the DHCP process may time out. The result is that an IPv4 client will not receive a valid IPv4 address. So the issue with these two stages is this: ZEPA listening and per learning. Dzinoenda no clash near DHCP because DHCP probably pamunosenda ma-request, pamunoita discover, pamunoita offer, pamunoita request, moita acknowledge. The whole process yekuda kupiwa IP address in a specific time yainoita, right? And the time iyoyo kana iri less than, let's say 30 seconds they're in between listening and learning. Zvinoreva kuti pamunosenda mapackets ako, pamuno exchange information neserver rako kuti ndikuda IP address, iwo switch rako rinenge risati rasenda anything, rinenge riri listening ne-learning phase. Zvireva kuti response haiuye from the server, zvireva kuti ma-end devices, they won't have my IP addresses, and that's a problem. So we have port fast being configured pama-ports, pama-access ports basically. Pama-ports ari pama-switch are connected to my end devices, my PCs, right? If we have another port, let's say we're going to switch, you don't configure a port fast panel, it causes more problems. Problems, loops ipapo. So port fast configure to this port, access port, reattached to the PC. Why? Tichirisa go so that PC yedu iyi paino request a DHCP, it doesn't get affected ne switch rako parinenge riri pa listening and learning port states. Right, so basically that is what the port fast is. Then the BPDU guard. Right, the BPDU guard, it enhances security by shutting down a port fast enabled port if it receives a BPDU. Right, we'll look at this further, but here discussing your security. Now that you have configured port E as port fast, zvikureva kuti normally port iroro rarifanira receive BPDU. Port raconfigure port fast rarifanira receive BPDU. Rika BPDU is probably mostly from an attacker. So attacker anogona kuuya obvisa switch rakwe, obvisa PC kana obvisa switch raka, iwo waconfigure port fast on this port. Zvikureva kuti switch iri rane access to hapasisina learning and listening and learning phase. Switch iri rakuconnecta directly to port fast rakubypassa mamwe ma-learning state, rekuti rinokwanisa kuonekwa nekuzivikanwa kunzi MAC address yacho ichii. Attacker ndo zvaanokwanisa kuita. So BPDU guard zvarinoita, pawaisa port fast unoconfigure BPDU as well, BPDU guard, so that port iri rikangoona pakuexchange message yeBPDU rinoziva something is wrong, it shuts down the port. And that's how it prevents an attacker from using that port. As long as it's being used as an access port pan a PC does not send my BPDU. Switch don't send my BPDU. So as long as pan a PC, upon a BPDU nowhere. So ringo bypass my listening and learning states. And basically that's what port fast and BPDU guard is. Right. And with that, a conclusion of STP. Right, this is a very important topic. Very important topic overall in networking. Although at this level, arena aroma configurations, it might feel like it's nothing, it's not a big topic because aroma configurations, but take it as seriously as you can, because a lot of questions can come from this. If you are focusing on the exam, the final certification exam, a lot of questions can come from this. From understanding what is a layer 2 loop, what is a broadcast domain, election process, you need to be able to know my bridge IDs, no say, my priority values, my MAC addresses, no say to determine the root bridge in the EP. How do I use my path cost to determine my route port? How do I identify with my designated port in the API? And which port do I block? We had some confusion with what to use, the bridge ID or the path cost. All right, I just looked, it's definitely the path cost. But those are typical questions that you can have kutoone kuti STP iri kufunctiona sei. So take this course very seriously. Let's not tend to focus on my course route or configurations a lot. My questions are nowhere STP overall because you skip that course, you skip that module, thinking, okay, no big deal. Thank you very much for giving me your attention. Done.